Good morning to all of you. Very good morning. So I think we are live. Yeah. सबसे पहले बोले now here. Is my audio video is clear to everybody? Audio video check करके बोलिए now. Is the audio video is clear to everybody? Do comment करके बोलिए. Right. चलो. Yeah, so सबसे पहले so we have the great news to all the aspirants who are seriously preparing for 2027 2028 के लिए. So अगर आपका ड्रीम IITs या PSU में एंटर होना आपको ड्रीम है तो जरूर अनअकैडमी पर ज्वाइन करो. सो हियर इसलिए हमने आपके लिए बढ़िया से बढ़िया ऑफर लेकर आया. दैट इज जस्ट what will be now 9,999 only. So here अगर इसमें ज्वाइन करने के लिए तुरंत आप BB रेड्डी का कोड यूज करके अनअकैडमी प्लस पर ज्वाइन करो टू हैव द ग्रेट लर्निंग एक्सपीरियंस फ्रॉम अनअकैडमी. ठीक है. And the Unacademy Gate Rank Predictor for 2026 के लिए which is live. You can utilize it to know your exact rank, more accurate rank. You can able to predict it. You can simply copy the response sheet and paste in the Unacademy website. Then you can able to predict the accurate rank. And the special class festival is live. So from the 5th to 7th, so utilize it. Here you will get to know the top educators classes. You can access it. That too free of cost. And we starting a new batches from the 13th March से शुरू होने वाला analog electronics by Shishir sir. You can see. And these are the ESC 2025 rankers from Unacademy. You can see many rankers are there. Unacademy starters kit is available in the stores. You can utilize them. And the another great feature is your new friend, that is Unacademy Una. So with this fellow will give you the company for your preparation. So this fellow will answer all your queries. In the 3 different modes are there: voice mode, quiz mode, smart summaries. And you can talk to Una to clear all type of small doubts. And you can directly interact with the educators also. Right, so test series which is live, you can utilize it. And we do offer the 2 subscription, that is what Elmina, one is plus wala, the other one is iconic. Plus में आपको क्या चीज मिलेगा? Top educators classes, live doubt solving, evaluated mains test series, structured courses PDF, live quiz, अनलिमिटेड एक्सेस. इसके साथ आइकॉनिक में एडिशनल बेनिफिट्स क्या है? पर्सनल कोच भी मिलेगा एंड फिजिकल नोट्स भी आपको मिलेगा. राइट. According to your time convenience, you can book a slot and interact with your mentor. Let's crack it. So these are the 2025 का rankers you can see. And चलिए आज का सेशन हम शुरू करेगा one by one. And the most important problems for the बात के लिए हम डिस्कस करने वाला. ठीक है. Yes. चलिए let's talk about one by one problem. Take this thing here. The current in a conductor is expressed as like this. They ask him to find the amount of electric charge that flows through a section of conductor during 1 to 2 seconds. Right. They given the current is given. They ask him to find what will be now charge. So tell me now how we can get the charge from current to tell me. That is integral of I into dt. So they asking to find the charge from where to where. You can see now here in the time interval of, that is t equal to 1 to 2 seconds, current which we have, what tell me now, 3t square plus 4t cube into dt. Now simplify this, will come it as what tell me now, 3t cube by 3 plus 4t power 4 by 4, and the limits are what you can see now, 1 to 2, and you can cancel it now here. So this 3 cancel, this 4 will get cancelled. तो हमको क्या मिलेगा, you can see now q is equal to upper limit which is equal to 8 minus 1 and plus what element of here, 2 power 4 16 minus 1. तो क्या मिलेगा now, this is 7 plus what element of 15. So how much is value, 22 coulombs. All of you do comment करके बोलिए आंसर क्या है आपको. Next one, and take the next problem. A wire of resistance 160 ohms is melted and drawn a wire of 1/4 of its length. 1/4 of its length. Then the new resistance of the wire is. I have a wire of resistance. We have a 160 initial resistance of the wire. So if I call this initially the length L1, which is equal to L, and this final length they given us what element of here. So this is L by 4. The new length is given as L by 4. Now you can tell me now here, with the same material they melted and they made in the form of a new wire of length is L by 4. So you tell me now here, whenever the resistance which is twisted, melted, drawn, elongated, compressed, what happens? Volume remains constant. So that is, we can say rho L by A. So I am multiplying and dividing with L here. Then will come it as rho into L squared by A into L is a volume. Here you can see now here, this wire is made of a same material, so that's why rho constant, and the same amount of material, so volume also constant. So from this, what I can say now here, resistance which is proportional to what I can say, tell me now, L square. Now you can tell me now here, L R1 by R2, which is equal to what you tell me now here, L1 by L2 whole square. Now you can simplify now, this is 160 by R2 and which is equal to L1 is a L, L2 is L by 4 whole square. Now simplify it. So how much will come? That is 160 by R2, which is equal to what, tell me now here, that is 16. That is R2 equal to what, tell me now here, 160 by 16. That is R2 will come to be what, tell me now, 10 ohms. Next one. The charge flowing in a conductor changes with time as given as like this. The minimum, so the given minimum value of current is the given charge given, the charge flowing through the conductor. So this is Q, which is given as what tell me now, alpha T minus beta into T square plus gamma into TQ. Minimum value of current. So first I am getting this current, you tell me now here, where current which is equal to what I can say, tell me now, dq by dt. So find out this current, that is alpha minus 2 beta into t plus 3 gamma into t square. Now this is the current. They are asking what tell me now minimum value. To find the maximum or minimum value of any function, will differentiate and will equate it to 0 now tell me. So I am finding this as what tell me now, I dash. Means one more time differentiation if we kiya to. Tell me now what I will get, to tell me now if I differentiated. So I will come it as 0 minus, that is 2 beta plus what tell me now here, 6 gamma into t, and will equated the I dash equated to 0 now. Then by simplifying this thing, we'll get this value of t will come, that is given as what tell me now, 2 beta by what we have tell me now, 6 gamma, which will be equal to what you tell me now, beta by 3 gamma. This is what you tell me now. We got the, at this time the current is, we have a minimum. To get this minimum current, we can substitute the value here now. Then if I substitute the t value in the above equation, so we can get this as a minimum value of current will come. It should be equal to, yeah, what you will get, you tell me now, this is alpha minus, yeah, that is 2 beta into t. T is equal to beta by 3 gamma, right, plus 3 gamma by t square. That means beta by 3 gamma whole square. So then what I will get this thing here, I minimum, which is equal to alpha minus, will come it as 2 by 3 beta squared by gamma plus, will come it as what tell me now here, 1 gamma square will get cancelled, 3, so it will come to be a 1 by 3 beta squared by gamma will come. So then simplify it now, how much will come? That is alpha minus this value beta squared by 3 gamma. Beta squared by 3 gamma. So this is the value of a minimum current. Check the option now here, alpha minus beta squared by 3 gamma. Got it everybody? Next. A 1 meter long wire is broken into two unequal parts. Is broken into two unequal parts, X and Y. The X part of the wire is stretched into another wire W. Length of W is twice the length of X, and the resistance of W is twice that of Y. Find the ratio of length of X and Y. Yes, so they given it as what? Tell me now. First of all, the length of this wire is given as what? You tell me now, 1 meter. Okay. It is broken into two unequal parts. So this means this is X if I call, and this is Y I'm calling. Unequal length we don't know. Okay. Next. The X part of the wire is stretched into another wire. So this will be X part. So if I say the resistance of this X, I'm calling it as Rx. Resistance of this Y is Ry. And this is stretched into another wire W. This C is stretched into another wire. Okay. Length of W is twice. They given it as what? Tell me now here. So the length of this W wire, so this is given length W. This length is given as twice that of X. That means resistance of W will becomes as what? You tell me now here. 4 times R proportional to L square now. So that's why it is Rw equal to 4 times of Rx. And the resistance of W, they given as resistance of W is twice that of, they given it as resistance of W. Resistance of W, they given as what element of twice that of resistance of Y. Okay. Now you tell me now Rw equal to 4 into Rx, which is equal to what? Tell me now, 2 into Ry. So it will come to be a what? Tell me now, 2 into Rx, which is equal to what? Tell me now, Ry. 2 into Rx length. So this means resistance is given as rho into, that is Lx by A, area of cross section. And this is what? Tell me now here. That is rho into Ly by area of cross section. We need to find this Lx by Ly now. So this is Lx by Ly, which will come to be a what? Tell me now, 1 by 2. So this is second options. Got it, everybody? Next, try this one. For the current shown, the value for the circuit shown, the value of current at t is equal to 3.2 seconds is. For this, we need to see what tell me now here. The supply you can see now here at 3.2. 3.2 means somewhere here now. And we can get this equation of the straight line. What I can say, this is V of t, which is equal to slope is how much now? 5. That is 5t plus c. C value constant we need to get now. So at t is equal to 3 seconds, current is 5. We can use this condition to get the t value. So now at t is equal to how much now? At 3 seconds. And this V of t they given us what? You tell me now, that is 5. Put this condition here. 5 equal to what? Tell me now. So this 5 into 3, 15, 15 plus c. So that means c equal to how much? You tell me now, minus 10. So from this we got the V of t value. How much now? That is 5t minus 10. Now we need the current at t is equal to 3.2. So we need the value of voltage at 3.2. At 3.2, how much this value you see this thing? at 3.2 seconds, we can get the V of t value how much now? That is 5 into 3.2 minus 10. So this is 15, 16 minus 10, which is equal to how much now here? 6 volts. That means at t is equal to 3.2, this is 6 volts. Now we can get this value of current now here, that is 6 minus 5 by 1. So that is how much this value you can see now here, 1 ampere. So this BARC test now, the problems are like this. Yeah, more twisted problems you will find. You know the concept, but they will ask in a different way. They will ask. You need to identify the logic behind that. Next, a wire of 1 ohm has a length of 1 meter. It is stretched till its length increases by 25%. The percentage change in its length is, yeah, we have stretched now. What happens? You tell me now. Whenever it is stretched now, volume remains constant. That means R proportional to what? Tell me now, L square. So it is stretched by this length is 125. So if I call this as here, and if I say this is initial length L1, if I call this as 100, and what will be the L2 now? It is increases by 25%, means 125. So we need to find the percentage change in the resistance. That is R2 by R1 will come to be a what? Tell me, L2 by L1 whole square. So that is R2 by R1 minus 1. If we add it now here, L2 by L1 whole square minus 1. They ask in the percentage of change now. Percentage of change means what? Tell me. That is given as R2 minus R1 by, that is R1 into 100, which will be equal to what you will get now here, L2 by L1 whole square minus 1 into 100. And you can simplify this thing, L2 by L1, that is how much now? 125 by 100, and for this whole square minus 1 into 100. So will come to be a what? You see this thing here, 5 fours and 5 fives. So will come to be a what? Tell me now, 25, 16 by 16 into 100. So this means 4 fourths if I do here, and then we can say this as 4 25s na. So simplify, how much will come? So this is 9 na. So this value 9 into 25 by 4. 9 into 25 by 4. So how much will come here? 56. Then this is delta R by R into 100. This value how much now? 56.25%. Next one. The charge on a capacitor plate in a circuit is a function of time. They given as like this. What is the value of current at t equal to 4 seconds? At t equal to 4 seconds, the given charge given. Tell me now here, basically charge and capacitor. So this current is given as what? Tell me now. Basically dq by dt. So you see this thing at this location at t equal to 4 seconds. You tell me now here. So this value current, which is a charge, remains constant. So that's why current will becomes what? You tell me now, 0. Next, in the given figure, R1, R2, R3, R4, and battery is ideal with EMF 12 volts, equivalent resistance of the circuit, and the current supplied by the battery is. They ask him to find the equivalent resistance and this current they ask him to find. So tell me now equivalent resistance of the circuit. Now tell me, we should find this R equivalent and then this current we need to calculate. Yeah, tell me now R equivalent is, so this R3, R4, R2, all these are in parallel. So how much is equivalent you see? So this value, R2 value is 8. 8. So you see this thing 8, 4, 8 are parallel. 8, 8 will becomes what? Tell me now 4. And this 4, 4 will becomes what? Tell me now. This parallel will become 2. And 2 and R1 10. So this is R equivalent will becomes what? Tell me now. That is 12 ohms. And thereafter we need to find this current now, which is equal to how much now? 1 ampere. So this option D. Next, equivalent resistance of the following network is. Equivalent resistance of the following network is. So A and B. So you can see now here, if we see here, this is the short is there now. So that means this element, dead element banega, there is no flow of current. And so you can see this thing here, fine. 2 and 2 are parallel will becomes 1. 1 plus 2, 3. 3, 3 parallel, 3 by 2. Yeah, will be. So 3, 3, 3. So this means RAB, which will come to be a what element of 3 parallel to 3 parallel to 3, which will come to be a what element of 1 ohm. Next, the potential divider circuit is shown in figure. The output voltage V0 is. So that means we need to find the voltage across these combinations. Yes. Now here this is how much now? 1, 2, 3, 4, 5. So this is 400. And this is how much now? 3.5K na? 3.5K, 3,400. So if I call this is R1 and this is R2, we need the resistance or voltage across R2. So generally, how many marks, that we cannot say. We cannot say how many marks can be happens. They will shortlist now and so generally they will call for interview 1:3, 1:10, like that they will call. Okay, based upon that, after that in the interview they will see. And the written test is just for 1:10 ratio they will call. And thereafter they will filter out in the interview, they will filter out completely. Okay. And so if you can perform well in the written test, then this will be advantage in the interview. So we need to get this voltage across the second R2 value. Na? So that is given as R2 by R1 plus R2 into, so this value is a 4 supply voltage. Safe zone that we cannot comment. Why? Because that depends upon the competition. That depends upon the competition level. How many number of students are attempted. So how students has performed in the corresponding exam. So that's why every year it will changes. Every year it will keep on will update. So now earlier you can see now here the less number of fellows are going for the core jobs like this gate they used to prepare. Now as you might be seeing this year many of the students are prepared for the gate because of the lack of jobs in the IT sector also. So many layoffs are happening, you might be know. So that's why. So then try to perform at most, at max you try to perform. Yes, 3,400 plus 400 into 4. So you can tell me now from this V naught equal to, so this is 400 by 4,000. 4,000 into 4. So you can see now here. So these two zeros will get cancelled. And this 4, this is 10 times now. So this value will come to be a 0.5 volt. So this is an option. मेरा comments आपको नहीं, yes, visible ना? Tell me comments are visible. हाँ. In the given figure, the charge stored in the 6 microfarad capacitor where the points A and B are joined by a connecting wire. Tell me now here, if I join this A and B by a connecting wire I have joined, then tell me now here, and this 9 volts which is a DC supply na, DC supply for DC case, as we know, how the capacitor will behave, so tell me now. For DC and capacitor will behave like a open circuit now, tell me. So then as a result, the flow of current, you tell me now, this current will flow like this and thereafter like this and it will flow to the ground, isn't it? They ask him to find. So that means how much is flow of current, you tell me now. So this value which is equal to 9 by 9. So this value which is equal to 1 ampere. Now here this current we have 1 ampere. So that means how much is voltage, and this voltage across the 6. So that means voltage across the 6 farads is how much now? 6 micro is, and which is equal to 6 volts. They ask him to find what will be now charge. Charge is equal to Q is equal to C into V na. C value 6 into V value another 6. So this value, how much is Q value? Tell me now. That is 36 microfarads. So digital may be common, but आपने so here so मेरा पूरा फोकस है इस क्लास में फोकस करेगा. ओके. सो हियर कभी कभी टाइम्स मैंने तो कमेंट्स नहीं देखने वाला ना, इसीलिए. सो समटाइम्स सो हियर ये कमेंट देखने के लिए मैं सो आई आल्सो हैव टू ओपन द व्हाट्सएप, सॉरी आई आल्सो हैव टू ओपन द यूट्यूब ओपन करना पड़ेगा. सो दैट मीन्स इधर उधर देखना तो थोड़ा मुश्किल लगेगा, इसीलिए आई डोंट use sometimes. I may not be seeing your comments. right? Next one. So here a बार्क का प्रॉब्लम तो बहुत बहुत लॉजिकल प्रॉब्लम्स मिलेगा, इसीलिए पूरा ध्यान देने के लिए कोशिश तो करो सभी ने. In the given circuit, the current flowing through the resistance 20 ohms is 0.3 amperes. The current flowing through this one. Here, this current they given as what we can say arrow given like this now. Have taken this current is 0.3. I have considered they given. And the ammeter reading they given. This ammeter reading which is given as what will be 0.9 amperes. Right. So you tell me now. So now here अगर हमको voltage find out करेगा ना current तो here. So how much this voltage across this element you tell me now here, and which is equal to how much this voltage 0.3, yes, into what element now 20, which will come to be what element now 6 volts. So either the voltage is 6 volts. Yes, अगर इधर this voltage 6 volts है तो this voltage is also 6 volts only ना. So can you find this current now? Can you find this current? How much this current you tell me now? If I call this current is I1, so tell me the I1 value which is equal to 6 by 15. How much this value tell me now here? 3 2s and 3 5s. So this value equal to what tell me now? 0.4 amperes. So this means either 0.4. So this is 0.9. So either current कितना होना पड़ेगा you tell me. So this is 0.7. This current must be a 0.2. So this means the current passing through this R1 is how much you tell me now here? 0.2. So this current, if we call this current is I2. So yeah, I2 का value देखो इधर how much now? Which is equal to 0.2. So अगर इससे हम we can able to find the resistance also we can calculate now. अगर if they are asking to find this R1 resistance, tell me now here, which is equal voltage we have a 6 volts now, that is 6 by 0.2, which will come to be what are you now 60 by 2, which will be equal to how much now 30 ohms. Next, in the network shown below, the charge accumulated in the capacitor in steady state is the charge accumulated. So this means what type of supply here you can see now DC supply, right? Tell me now here for DC and capacitor will behave like what? Tell me now open circuit हो जाएगा. So that means this is effective resistance is 10. So that means how much is current you tell me now here? That is 3 by 10. 3 by 10. So this value which is equal to 0.3. 0.3 amperes. And what is this voltage you tell me now? This current is I, we got it as 0.3, which is equal to what we can say now 6 into I. That is 6 into what we can say now 0.3. So this V value is how much now here? So this is 1.8 now. 1.8. This is the voltage. Now from this we can get it as what will be now here? Charge we need to find. So the charge which is equal to how much will come? So that is Q, which is equal to C value 4 into what will be now 1.8. So this is 7.72, that is 7.2, which is microcoulombs. Right. Next. Here you can see this thing here. They ask him to find the current through this R2. So here they are asking the current passing through here. This current we need now. Okay, let us call this is something Ix. If I call Ix, will find. Yeah, first of all, you see this thing, find the equivalent resistance. Yeah, first of all, you tell me now 2 and 4. These two are series, will come 6. 6, 6, 3. 3, 3, 6. 3, 3. So this value 6, 3. This is 6. 6 and 3. 2. 2, 2, 1. Yes, 2, 2. This is 1. 1 and this. So here anyway this voltage is 5. So this current, how much this current is coming, you see this thing here, overall this whole part. First of all, this whole part is how much, you see this thing here, which is a 6. This 6 and this 3 will come it as what, help me now, 2. So 6, no, this 6 and this 6, which will be a 3. So 3, 3. This is what, 3, 3, which will become 6. And this 6 and this 3 will become 2. And this 2 and this 2, which will becomes 1. Finally, except this thing, this same voltage here also, na. That's why. So that means how much current going here, you can see now here. This current, which is equal to 8 by 1, that is 8 amperes. Okay, now we can see the current flowing in the other branches. So this 8 will go here up to here. Next, then here. So here what we have, tell me now, this remaining this currents, you see how much this value, tell me now here. This is 3. So this value 6, 3, and this is, so this value 6. This with this 3, 3, 3, and which is equal to what, tell me now here. So 6. तो द कंफ्यूजन हुआ क्या, और एक बार करिए, सम इशू इज हैपनिंग, आई थिंक सो. If I redraw this thing to avoid the confusion, now here this is the ground only, then how much this voltage here, which we have 8 volts only. Okay, 8 volts, and so then this current, how much will go here? This current 2 amperes will go here. Then remaining equivalent part, will see this thing here. Equivalent resistance. How much the equivalent resistance, you tell me now, ek bar. So these two, how much now here? 6 first. 6 and 6 will becomes as what, tell me now? 6 and 6, 3. Yes, 3 and this 3 will becomes what, tell me now? Series will become 6. And the 6 and 6, 6 and 3, 2. Here we have this part is 2. Now, that means this is 2. Here also we have a 2 now here. This whole part, this part is 2. I'll better redraw this thing to avoid the confusions. Hmm. I have taken the supply here. Right. So this is 8 volts. Right. Thereafter, you can find here is a resistance. This point which is a E and this point which is a D. Okay, this point is A only, and from A to D they has given. So how much this resistance is given? This whole thing is A. Next, D to C. Here this is a C. This point is a C, and C to A. This is the one element they given, and C2 this is B, and this is A. So this is given. This is B. Okay, the whole thing is A. Yeah, now you can tell me the values now here. Here we have this is how much now? 4. And this value 2. And this value 3. This value 3. And A to C, this value 6. And then this value 4. And this value 2. So finally we need the current in where? 4 ohms. Means here we need the current. This current, let us say Ix. Okay? Yeah, you tell me now here first. So without any confusions. Yeah, first of all, what we can say now here. So this whole combination, which is equal to 6 now, tell me now. This 6 and this 6. And here, which will be a 3, 3 and 3. 6 now here. Up to here, this is again will come 6. 6 and 3, which will becomes what, tell me now? This is 2 now. 6 and 3. 2. 2 and 2, so which will becomes as what, tell me now? 1. Okay. Now you tell me now here, in this case, up to here, so this voltage, how much we are getting, you see this thing? So then this one, here anyway, this value which is equal to 4, this value 4 volts and this voltage 8 volts only. Okay, now you can see now here in this case, so here 1, this value 4 now, 4 ohms, 1 and 4. How these two you tell me now? How these 4 are? This is 1 and 4 are in parallel. So this is 1 into 4 by 5. So it will come to be what, tell me now? 4 by 5. Now from this we can get this current now, tell me now, which is equal to 8 by 4 by 5. This 4, this is 2, which will come to be 10 amperes. So here this current which I am getting it as how much, you tell me now? 10 amperes. Now how much this current, you tell me now here? 2 amperes is flowing now. That means how much this current is? 4 amperes will go here. Now here up to here this is 4. Either aane ke baad you see this thing, this is 3. So here we have a resistance. In this branch we have a 3, and in this branch how much the resistance now? So this value 6 and this is 3. Up to here you tell me now here. So this value 4 ohms will come now. Here we have a 3 ohms is there, and here how much this value? 6. That means current has to be divided. So this means in this branch current, if I call this as a I1, so tell me now how much this I1 now here? which is equal to 3 by 6 into 4. So 3 2's, now this value 2. So means this current which is coming, it is a 2 amperes. If this is 2 amperes, now you tell me now what happens, you see. So we need Ix. So the current will divide between these two. Now tell me here. Huh? 1 ohm is incorrect. Why 1 ohm is incorrect? कोई गलत किया क्या मैंने? Huh? 1 second. So this is 6. Not correct. 1 second. Let me check once again here. Okay. Some confusion created here. So this is 6 ohms. 6 6, which will be a 3. So here 3 3. Okay, this is 6. Okay, let me check once again. So this value we can say this value which is equal to 6. First thing, this is 6 and 6, and here we have 6 only. So this whole part, this part is 3. Okay. Okay. So this whole part, so this is 6 6 6. Okay, this is 6 and this also 6 will come it as 3. 3 will come. This 3 and this 3. How these two you tell me now? Series will come it as 6 now here. 6 and 3, which will come to be a 2. Okay, up to here we have this resistance is 2. Tell me now. Okay, now 2 and 2 are in, okay, series will become 4. Okay, 2 and 2, this is in series, will become 4. 4 and 4 will become 2. Yes, 4 and 4 will become 2. So that means the current which will come to be how much now? I is equal to 8 by 2, which will be equal to 4 amps. So that means the current given by the source is how much now here? 4 amperes. Okay, now this current which is equal to 2 amps, now इधर आने के बाद this 2 amperes current will divide between, so this value 6 and this value 3. If I call I1, so that is how much is I1 value? Tell me now. 3 by 6, 6 plus 3, 9 into 2. So this value 3 3. So which is equal to 2 by 3. So here we have this current is 2 by 3. This current is 2 by 3 amps and this current 6 6 1 by 3. Yes. Check करके बोलिए now. This is 1 by 3 is a correct answer. हमने थोड़ा, so here either 2 2 is a series ना, so इधर हमने गलत किया. So here previously I was in S only. आपको कैसा पता? मुझे देखा क्या उधर? आपने देखा क्या मुझे पहले? Right. Next, you can see the equivalent resistance of the circuit shown below between the points A and B is. We need to find the equivalent resistance between A and B. A and B we need to find. This is A and this is B. Here we can apply the perpendicular symmetry. We can apply now. When we apply the perpendicular symmetry here, then see what happens. You see this thing here. Then this element will become a dead element. We are applying a perpendicular symmetry here. perpendicular symmetry we applied, so that as a result, it will becomes dead element now here. Then we have see the connections now. What will happen? Now this is A and this is B. This one. Yeah, check karo now here. So this is how much now? 4. This is 4. And this is 4. And this is 4. And this is 16. Now you tell me now 4, 4. These are in series. 8. 8. 8, 8 will become 4. Parallel. 4 and 16. That is RAB, which is equal to what? Tell me now. 4 parallel to 16. That is given as 16 by 5. So how much this value? Tell me now here. 3.2. Okay. Ace Live versus Unacademy. So you see this thing here. Whichever you are comfortable, you do follow that one. You compare both now here. You compare both. There are some also in Unacademy. There is no restrictions. You can join in any batch. You can join any educators class. You can attend any number of times. You can watch. But in the other things, there will be restrictions are there. You can watch only 1 time, 2 time only. You are not allowed to watch more than the 2 times the same class. So there is a restriction in there. You can watch only 1 time, 2 time only. You have to watch it. So here more than that, it is not possible to watch it. But this Unacademy, there is no restrictions. You can watch the classes any number of times, any times until your subscription get complete. You can watch all the subjects, all EC electrical subject. You can able to watch it. 10 resistors, each of 10 ohms, can be connected in such as to get maximum and minimum equivalent resistance. The ratio of maximum and minimum equivalent resistance is. Yeah, you tell me now. 10 resistors, each are connected in. So here each are value given as 10. You tell me now when to get the maximum. When can happens now? When the resistors are connected in series, then only we have a maximum now. That is how much this value? 10 into 10, isn't it? How much this value? 100. When the resistors are connected in series, then we have a minimum. That is how much now? 10 by 10, which will be equal to 1. They asking to what? Tell me now. R max by R minimum. So that is how much will come here? 100. Next, the equivalent resistance between A and B shown in figure is. Equivalent resistance between A and B. Yeah, you can see now here this is point A and this point is B. And this point, so it is also equal to B only now. This point is also equal to A only. Now you can place the resistors now here. I have only 2 points are there. One is Yeah, this is A. The other one, which is what you tell me now, B. We have A to B. This is the resistance we have. How much this value tell me now here? 20K. And again, A to B, B to A means both are same only now. So this is how much we can say, that is 20K. Next, A to B. How much is A to B they given? And which is equal to 10K. So this value 10K. Now you can tell me now here, these two are in parallel will becomes 10K. 10K, 10K parallel will becomes 5K. So that is RAB will come it as what, tell me now, 5 kilo ohms. Next one. Equivalent resistance between the adjacent corners of a regular n-sided polygon of uniform wire of cross section is given. They ask him to find what, tell me, equivalent resistance now. Yes, for our simplicity purpose, we have considered this as n value we have taken as a 4, and let's analyze it. N value 4 means the circuit is what I can say, tell me now, square. So we need to find the equivalent resistance between the adjacent sides here. This is A and this is B. And equal resistance now here. So we can say now this resistance all will have a equal resistance. Now this whole part so will come to be what, tell me now, 3R. And then parallel. So that is RAB will come to be a what, tell me now here. So that is 3R into R by what, tell me now here, which is equal to 4R. So that means how much this RAB, which is equal to 3R by 4. And you can see now which option will satisfy. Verify the options. Now, so you can see now first option may n value 4 if we place now will come it as what, tell me now, 3R by, so 8 minus 1, 7 will come. So galat na. And second option may, so this is for 16R by 3. That is also wrong. C. So this is 3R by 16. So no. Here option D, which we have 3R by 4. Yes, correct na here. Right. So like this we can verify these things like this. Okay, fine. Yeah, that's it for today's session, and tomorrow also we have the same timings around we have, and we'll continue the remaining problems will continue. Okay. Okay then, see you. Bye bye.